Hi guys, my student ID is 103900131. Today I'm going to analyze DNS using Wireshark. We're gonna look how it works and how it looks like in Wireshark. Now let's just start capturing the packet using my local interface, that is Wi-Fi in my case here, and it will start capturing the packages. Just quick review, the Wireshark is divided into three sections over here. The first section represents the packet list, and the second section displays the packet details, and the third section displays the packet bytes. Now we can see the different protocols over here, and now we are going to analyze for DNS. For that, I'm quickly going to my browser and look for request for facebook.com. I'm minimizing my browser, and then I'll stop capturing the packages. Now I'm going to look for DNS under the protocols. There is few ways to do that. Either I can do by scrolling into the list, or either I can do with typing DNS in the filter bar. We will return all the DNS protocols with the standard queries. So I'm going to look for facebook.com over here. I'll go with this one, and it has a transaction ID this. So the transaction ID for query and the response are similar. So I'm going to look for the corresponding response for this query with the same transaction ID, that is this. There's another way to figure this out, is follow these arrows. This arrow represents the standard query, and the other arrow represents the corresponding response to that query. Now, just a quick review. We can also figure out few details about this query over here. For example, with Ethernet, we can figure out the destination IP address, then the source IP address, that is my system, and that is the IP address of my system. And then, for example, in UDP, I can figure it out the source port and destination port, that is 53 for DNS. And we can also use transaction ID in our query header as a filter and find the corresponding response. Now the flag structure for both query and the query response are similar. I'll go with the query first, and it has, when we expand, it has a few flags. It shows recursion desired true. So the response over here simply means if the message is a query or a response. If it is a query, it will be 0, and if it is a response, it will be 1. Opcode that represent what kind of query you are running, like standard query in this case. Truncated, it just tells the packet size. And then the recursion desired to query recursive, it means query is requesting to a DNS server if it knows the answer to the query. If the server do not know the answer, it will continue sending the packets to different servers until the correct IP address matches. And then Z reserve, it simply returns yes or no, which means it is either it is reserved or not. It is reserved for future use and must be 0 all the time, even for the response. And then we have 4 different parameters. First is the question. The question is the value provides the number of it is the value that provide the number of requests that are sent in a DNS query segment, and then these RRs are the resource records. And we can also use query response is in 143. So it just simply direct you to the response of the corresponding query. So that is the time calculated by the Wireshark that represents a time taken by a query to response. Thank you.